I always forget something. There's always something in this multi-step process. Um, I'm slow moving. I hit an energy level around Friday that approached 0 degrees Kelvin. It was crazy. You ever do that? Of course you do. I'm slow moving. Hang on. This is you know what I mean, where just like everything just bogs down. Yeah, Jay, man, it has been an accursed year, and then I hope we emerge out, next year. I'm dropping real quick. I am just dropping the link, the live link, into the syllabus schedule, and if I do that live, it always happens. So let's see. No class, no class. Today is December uno, and we are a little bit behind. But here's the thing: this I need to find get a more accurate representation in the schedule. I don't know if anybody even looks at the schedule. We obviously kind of take it as it comes, but as I said before, some of the earlier concepts, like chapter 2, chapter 3, we'll spend like 2 weeks on one chapter, and which is why I tried to break those up into a little bit smaller modules. Later on, we're like module 10, 11, 12. Module 12 is less than a day. That is less than one class period, and 10 and 11 are usually around one, so we're fine on time. And as I said before, some of you are going to still, well, not you because you're here listening to this, but there are some that are like not attending class or watching lectures that are going to complain, for example, on SRIs, that the pace got real fast down the stretch. And this is not true. The pace has not changed. The counting has changed. But it's just like, you know what I mean? The content of absorption, the pace of absorption has actually slowed down. But the number of modules. Now, if I can find an alignment for that, I think it's better, pedagogically better, which is a fancy way of saying how to do good teaching. But just so you understand that we really are. So, now, are you still getting that sound? And is it me? Like, I'm going to try an experiment, because I was doing something the other day and I was hearing this kind of crazy mic sound, and I don't know if it was like a short in this cable.
Yeah, sometimes it goes in and out of like muffling, and then there's also like let's see. Like David said, it does sound like somebody's rubbing the mic. It's not sounding like that anymore, but it was, and we'll
Yeah.
let you know.
Because I'm just wondering if there's a short, right? You know what I mean? If there's a short in this thing.
Yeah, could be rubbing it up against that Pharisee beard though.
It could, no, well, it could, I guess, I don't know. Is that doing it? Is this it?
I don't know. That's my assumption.
No, but I'm
I
doing
really
live demo, though. I'm doing live demo.
not working, so I guess that's not it.
This is that is the mic, and this is the Pharisee beard. It's
Yeah.
now officially the Santa beard. It was a Stinky Pete
Okay.
beard for about 2 weeks. I'm getting that, though, and I don't know. I think my guess is it has to be this hardware somewhere, which means I got to do something. I also thought it could be like a short down on the plug or something. Anyway, I appreciate that feedback, because I've done that before. I did like a Facebook Live where I was getting this like really loud, very interfering kind of audio interference. I don't know. Got to upgrade my equipment. That's what I got to do over the break, over the holiday break. Okay. Hey everybody. Happy back from Thanksgiving. 2 weeks to go, and then finals. Let me see. Oh, and it's back. Nice. I have another idea. Let me try one other thing. I
Now it really sounds like your voice is channeled in. Yeah. Golden.
And I hit an energy level around Friday that approached 0 degrees Kelvin. It was crazy.
Yes, we can.
No,
All
we
right, thanks,
can't
Brad,
do it
for
all. I'm just kidding. I'm pulling you like
device
hear you.
AirPods. Okay, here we go. Okay, now we should be okay. We should still be good. All I'm doing is just adding it to the OBS stream. I only stream the video to Discord because the audio doesn't come through. Then we just go native on the voice chat on Discord. But on YouTube, it has to come through the streaming. And so I'm going to bring that up to current and just see
An
if
energy
I'm
level
getting
around Friday that approached 0 degrees Kelvin. And that is, I don't know, is that doing it? Is this?
Sorry, I'm just looking on YouTube right now. We should still to just see
An
if
energy
I'm
level
getting
around Friday that approached 0 degrees Kelvin. And
suck.
that is, I don't know, is that doing it? Is this?
Sorry, I'm just looking on YouTube right now. We should still to okay, I have another idea. Just see
An
if
energy
I'm
level
getting
around Friday that approached.
okay, if I go input there, I'm going to go there and then output there. And then I'm going to go different on Discord. Seriously, I'm so sorry. Input device, I'm going to stay with the AirPods on Discord. Okay, so quick sanity check. Am I still okay on Discord with audio?
Yes, you are. Can you hear us?
Yes, you're good.
Can you hear us, Dr. King?
I'm not hearing you. If you're talking, I'm not hearing you.
Oh, okay, he
Crapo.
can't hear.
Okay, you know what I'm going to have to do for now, just to get through this thing? I got to do one of two things. I got to go purely, yeah, I can see I'm going to go actually off this thing. I'm going to go pure, I'm going to go pure laptop input through the built-in mic. And yeah, I'm gonna have to debug this thing. Sorry, everybody. No, you know what? I gotta go back to this. So I'm gonna go back to the DOM. Okay, there's gonna be a little interference. I think it's the only clean way to do this without spending our entire time debugging this DOM. All right, let me try this now, and we're gonna be back in business. I'm gonna go external mic streaming. This is the known configuration, basically. And I can now hear sound coming from everybody. In fact, someone's got. I can hear you now.
Sweet.
External mic on the input and output is streaming. Yeah. Okay. And you can hear me okay. And there's going to be some whatever beard husking sounds that is just going to be equipment failure. Okay, let's do it. Apologies.
No worries.
I still think, all things considered, we've probably been more tech problem free than a lot of these sort of canonical options that were, you know what I mean? What am I trying to say? Like Teams and Zoom and things like that. The AirPods on. All right, and I got audio on YouTube as well. All right. In other words, there's always something. I mean, we're trying to do this thing. It's a thing. Okay, we're talking I/O. We are talking I/O. So, quick things. Quick things. Number one, you gotta get in the simulator. You gotta play with the simulator. Okay? I can do a help section where we can spend more time on the simulator to do some debugging and stuff. Okay? I'm happy to do that. Maybe just let's set a time and we can, if that'll help everybody. In fact, we can do help sections on about anything as long as I know that there's, enough interest that it'll make a difference and be valuable to somebody, right? Okay. All right. Thanks, Josh. Yeah, maybe it was the laptop mic to begin with. All right. Awesome. Appreciate the feedback. So yeah, number one, you gotta get in the LC3 simulator and play around. That's number one, okay, simulator. Number two, there is an acronym. It is RTFM, okay? Anyone know what that stands for? I'll wait. Read the effing manual. Yeah, this is an actual acronym in the computer/software industry. Read the freaking manual. Okay. Now, what that means is, now sometimes let me kind of clarify a couple things. Some of you are in the manual, trying to figure it out, reading it, and it's not clicking and it's not making sense. That's not RTFM. That's called I read the freaking manual. And I'm lacking some comprehension that's making that a little harder for me to understand. Fine. Then you ask the clarifying question. But some of you are asking questions either of the TAs or of me or hurling them out to the ether on the general chat that are kind of like, how's the one thing work? Look it up. This is in the real world of software. It's open book for starters. Real world of software is open book. Your documentation's open book. And your basics are like, go find some documentation that you like, that explains, that explains what the thing is, what the functionality is, how it works. I have posted on Canvas appendices from the book, one on the instruction set with all the individual descriptions. I pulled it up repeatedly. And I've also posted an appendix for the trap instructions, which I've also pulled up on the big screen. And trying to model that, for you. Same thing with ASCII tables. If you like, what's the ASCII value for thus and such? Look it the hell up. Google ASCII table. You'll get like 3,000 examples of an ASCII table. Pick one that you like, okay? What I'm trying to do, I know I'm being a little bit harsh, But it's a little bit exasperating, and the punchline here is not my exasperation, but it's a little exasperating in the sense that, look, you're trying to become software developers. You're trying to become software engineers or computer scientists. I don't even know what you're going to be. You're going to be developers of software in any case. You're never going to be handed everything you need, and learning is always going to be a big part of your activity. Always, always, always you're learning. Okay, for the rest of your life. All we're doing here in your undergrad is laying enough foundation of basics and some skills of learning. And then you can learn how to bootstrap and go, okay, once you have the foundations. But frankly, in a world of Google, for crying out loud, man, in a world of Google, you can get specific answers to specific questions. We're trying to help you with the framework, kind of guiding you through that big quagmire of all the stuff to say, no, here, this will help you the most. I'm going to guide you through this, and then another class will guide you through this, okay? But the key is, so Eisen just said, the difference between passive and active reading, yes, it's also the difference between owning your own crap, taking a kind of accountability, leaning forward in the skis, I call it, taking accountability to figure stuff out. If it's not handed to you and you don't know immediately what it is, you figure it out, right? And that is a critical skill, being a software developer, because you're always having to figure stuff out. And the doc is never quite right. The documentations are never quite right. And but you can't be like pinging Stack Overflow 37 times a day for the next question. You do that when you're truly stuck, but you start by figuring out how to find the answers and educate yourself. In our case, read the documentation. If you have the book, it's in the book. It's mostly also in the slides, and I've posted appendices from the book on Canvas, so you should have all the documentation that you need to do all the things, okay? So one of the things, last thing on this little rant, I will do this. Some of you have had me do it to you, and I've asked the TAs to do the same thing, okay? If you ask the TA a question, or me, that's kind of like, how does the blah, blah, blah work? The first question we're going to ask you is, have you read the documentation, and what is it about the documentation that you don't understand? Okay? You understand that is an absolutely fair question for us to ask, right? We can't, especially with however many students are registered for this class, 90, for the 2 sections, you can't be you can't be just sort of like coding by query. You can't just be coming to me or the TAs to get every piece of information, especially when A, it's in the documentation, and B, I did talk about it in lecture. So go back, look at the lecture, look at the slides. Also lecture, not just the slides. There have been some students, and I presume they're not here today or won't watch this, but there have literally been some students who had not read the book, the relevant chapter and sections, had not referenced the documentation on Canvas, had not looked at the slides, and had not watched any lecture, that were asking questions of the TAs about how do you do the one thing. Now, I just want to say, that's just not acceptable. That's really inappropriate, because there's a part where we do all the stuff we're trying to do, and we've been way available, right? We have been and continue to be super available. You have to do your part, right? And so if someone says, I watched this, they'll say sometimes, I hit the lectures, I've been through it, I'm really frustrated, I just can't get the one thing. And usually in 5-10 minutes, if you've done that, then in 5 or 10 minutes, I can get you over the hump. But if you haven't done all that, then all I'm really doing is doing one lecture for everybody, and then basically repeating chunks of that lecture individually for all of those who aren't, kind of taking more accountability, if that makes sense. I'm not trying to be harsh. I'm not a butthead. I try not to be. I'm just trying to be reasonable and understand there's a part that I have and there's a part that you have.
So what you
Yeah, go ahead, Eisen.
Yeah, so what you're saying is that if I'm understanding you correctly, is use all the resources that you can, like the book, the slides, all the
The
resources that are
lectures.
viewable. Lectures, yeah, of course. And they're I
Yep.
like how they're listed out, by the way. But use all those first, and then once your resources and things are so exhausted and you're stuck on something, then you come to a TA or you
Yeah.
to ask about a question. Is that what
Yeah.
you're saying?
No, absolutely. And I don't mean, don't come to me until you spent 6
Well, yeah.
hours, right? But you can like review it. It'll take you a little time to review it, double check it, try, you know what I mean? And then the other thing that relates in tying those two ideas together, the simulator and then that personal accountability, occasionally, and it's really interesting. I was talking, is Zach on here? Zach's not on here right now. He's usually is. But I was actually chatting with Zach about the fact we were talking about this idea, and he goes, you did that to me when I had the class. I'm like, no, what happened, right? And he's like, and he copied me on a chat that he had sent me when he was in the class as a student, and he had sent me some code, and he said, will this work? Was his question, right? And I said, drop it in the simulator and find out. You know what I mean? You don't need me I'm not your assembler. I'm not your simulator. I'll help you debug it when there's something that's not quite clicking. But drop it in the simulator and try it yourself. That's where the fluency comes in. That's where you take that responsibility. So anyway, that's my rant. It's a good rant. Yeah, go ahead.
It was a good rant. Thank you so much.
But and ironically, what's that?
It was a helpful rant. It was a helpful speech.
I'm trying to encourage the responsibility, which, by the way, is in fact, I'm not just trying to be easy on myself because I don't really optimize to that. I am trying to say this is a life skill. This is a professional skill, that you're going to need to figure out sooner or later. And I remember when that clicked for me as an undergrad. It was a particular class where I just realized that I could kind of just figure all kinds of stuff out, and I didn't have to be spoon-fed. I could figure crap out. Now, one other thing related to that. Ironically, all the people who most need this probably will never see this. But if it's helpful, I hope. One other factor, there are some of the questions where there have been comments to the TAs, less so to me, because I think people just, I don't know, it's the white hair, you fear the beard. And but the TAs have gotten more of this. But when there are some questions that are like the kind of the diagnostic debug things, like what's the instruction that had to have just run? What I'm trying to do with a question, the ones, what I'm trying to do with a question like that is get you to think diagnostically. Okay? That's what I'm trying to do with a question like that. It's not what's the answer? 7. Here's a binary number in 2's complement. What is it in decimal? -105. These are not those kinds of questions. The thought process is the deliverable, if you will. Now, you later on have to tell me what you give me an instruction. But the goal of that question is not the instruction. The goal is the thought process inside of you. Okay? And there have been a couple of times, very isolated, but again, I'm just going to say up front, really inappropriate, where somebody has approached a TA on a question like that, right? And asked hey, what I don't understand number whatever. And then the TA would say something like, okay, yeah, let's talk about it. So how do how have you approached it so far? Or what's the, what's like, for example, you look at the registers, what changes in those registers? It's a guiding process to walk you through the learning. If you understand stuff, it'll be really quick. You'll be like, well, that one. Okay. And then what does that make you think? Oh my gosh. And when somebody's engaged actively and responsible for their own learning, when you say something like, so why would that be? And then I've had this happen so many times, hundreds of times over my career, where you're like, why would that be? And then watch the student just go, Oh my gosh, no, I got it all. There was just a little mental block. You help them through because they've done all the other homework, if you will, about the rest of it. But in a couple of instances, very isolated, it's literally, and I've seen the chats, because they'll usually ping me and just kind of go, yo, Dr. K, is it, how should I respond? Or, you know what I mean? We're trying to collaborate and calibrate. Where the student's just like, well, if you're not going to help me, I'll just go look it up myself or something like that. Okay, I'm sorry, that's bullcrap. That's really, and I've watched the chat exchange to know what the student was doing and that what the TA was doing and that it was appropriate and that was an attempt to guide through a process. Because the fact that you're stuck on a question like that means you don't have the thought process. So that becomes the focus and the deliverable. And if you're looking for me and the TAs to just be like, what's the answer on this one thing? Okay, 11001111. Thank you. You understand how worthless that is? How pointless that is? And we're not going to do it. So we try to be respectful, try to be kind, try to be helpful, super available. But that on the part of the student who's like, very snarky and being like, well, if you're not going to help me, a little bit of an FU, that's just bullcrap. I'm sorry. That's really bullcrap. And it kind of pisses me off because we're not slacking on trying to be helpful, but we're not gonna take over your process of learning for you.
You just don't understand, Dr. K.
Chris.
I'm so oppressed.
Thanks, Chris.
You can always rely on me to help you out, Dr. K.
All right. Okay, yeah, anyway, end of rant, end of speech. But I just had to get that off my chest. I'm sorry. I had to get that off my chest. And then put on my chest my UVU swag, which I'm really proud of. I love this shirt. Okay, let's do it. IO, input, output. Ready? You're like, yeah, we've been ready for a while. We've been ready for a half an hour, Dr. K. And by the way, there's somebody, and I don't know if you're on here right now, but somebody's been super, super helpfully pointing, dropping comments in the YouTube videos about like, the one, this starts at this location. Any of that kind of stuff is super, super helpful. But the only risk I have is put context, right? I don't remember who's doing it, but again, I really appreciate it. I think it's great. But if you put any of those kinds of comments in the YouTube videos, put it in the context of like, IO starts at this location on the timestamp. That's helpful. Saying skip to whatever may or may not be helpful because I might be using some of that time to be giving these kinds of hints and helps and little speeches that if the people who most need that, if they skip past it, didn't hear the speech. So, okay, here's the deal. Let's do this. The deal is that we talked a little bit about this already. Okay. Hang on, that's not what I wanted to do. All right. The fundamentals of I/O. The idea here, of course, is that you've got to get stuff in and out, right? We did this part here already, that the LC3 only has a keyboard and a monitor. Real computers have a grunt load, a butt load, a crap load of I/O devices, okay? And a bunch of different ways of interfacing with those I/O devices. But one thing that's kind of common is something called device registers. Now remember that we've already talked about general purpose registers, right? R0 through R7. And then you kind of learned by doing the trap instruction that R0, you can use it like a general purpose register, but when you do like the trap instructions to put information out or to input from a key, R0 gets used, okay? So there's kind of a standard there. And when you do subroutines, JSR, that R7 gets used, but they're still general purpose, right? We talked about the control codes, which are individual 1-bit registers. We talked about the program counter, which is a register, the instruction register, which is a register. the MAR, which is a register, the MDR, which is a register, right? There's a lot of registers. And all that really means is small little chunks of memory, little tiny chunks of memory that have special purpose and special ways of kind of getting to, that are built into the computer. Okay, well, it turns out there are device registers that are built around this idea of I/O and communication outside the computer, getting stuff in, getting stuff out. Okay, and typically there are at least 2 registers, one for data and one for status. Okay. And the reason that we have that probably will be obvious very, very quickly. But, sorry, I was just thinking about something. I keep having I/O thoughts about the stupid configuration, which is going to be better next semester, which is also going to be online and streaming. But typically one for data, one for status. The data register is basically for output, it's where you put the data. For input, it's where you read the data from. Okay? And the status register just tells you, are you good to go? Can you, is there data to read? Or can I write the data? Are you okay if I write this data? That's what the status registers do. Okay? Let me see. Did I do that? Yeah. And then I think we may have talked. I think I got to this slide before Thanksgiving, but I wanted to back up just a little bit to give context. That we think of sending data as maybe we just think of it as like one thing. I'm going to email you a file, or I'm going to, whatever, upload something, or I'm going to play my music. You think of it as one thing, and by now you probably realize it's a bazillion little things that's actually happening. Lots of little steps, okay? And again, I kind of mentioned, this notion of output and input, that when you go to output, you start to send, but you need to know when it's done. Like, when can I send the next one? Because it takes a little bit of time to process the thing that I pushed out there. Okay, same thing with input. So there are, broadly speaking, 2 schemes for I/O. There are many schemes for I/O, okay? And there are hybrids and variants, but these ideas will give you kind of a foundation. And by the way, I've said this a bunch of times because I know that some of you are like, assembly, hate it. Even if you're going to go be a smartphone app dev, you're going to be a full stack developer, you're going to be, you're going to be a lot of these things. These ideas show up over and over and over and over again. Okay. In fact, if you're going to go build apps and you're going to do AWS kinds of stuff, you know what AWS really, really is, right? It's just computers in the cloud. And all the cloud means is they're somewhere else. They're literally physical hardware somewhere and virtualizing these things so it looks like your own little computer in a data center in Oregon or something, right? But whether you're doing AWS or Azure or, Google Cloud Services or whatever, I'm not trying to, be like unduly biased toward AWS. That's the most popular one by far. But I'm just trying to say, you go to try to like build your app and then you're like, oh, there needs to be a server side. Oh, we ought to probably do that on AWS. Guess what you're going to be dealing with? Scalability, amount of memory, amount of bandwidth, pipes coming in and out. You're going to deal with all this crap again and again and again in your career. Even if you just are like, I just want to do web pages, it's going to show up. Okay? So this is not like gag this down, throw it away. I'm trying to help you motivate. Motivation. Do you feel the motivation coming through? These fists are the fists of motivation. It's the best I got right. Wait, okay. This plaid monkey is the plaid monkey of motivation. Do you understand what I'm trying to say? Okay. The monkey is always with me. His name is Hubert. He's basically my only friend. Okay, let me keep going. Okay, so There's a couple ways of doing this. One is with specific I/O instructions, where you build in an I/O instruction that looks like an instruction, and the other one is with memory mapped I/O. Now, which we're going to talk about and uncork the mystery of memory mapped I/O. I would say that the LC3 is actually kind of weirdly almost a hybrid, because like the trap instructions, those are kind of I/O instructions, but they're not just I/O. They're all kinds of interrupts. They're all kinds of system level calls. But the LC3 is built in, like there's out, and there's in, and there's put S. What are they? Is that them? There's put S, there's out, there's in, C out maybe? I can't remember off the top of my head. There's only 5 trap instructions supported. Get C. Thank you. Thanks, Tyler. Yes, and all hail Hubert. He is my pal. Yeah, right. So I'm just saying that they look and act like I/O instructions. Like, I'll say get C. Now, the reality is that maps to a trap, which is an instruction. And then what the trap instruction actually does is causes to be called a routine somewhere. And we'll go into it, and I will show you the device registers for I/O in the LC3. Okay, and we're going to do it by taking something like get C, and by walking through it, and then going into that trap instruction and looking at the code. We're going to do it today. I hope. Yeah, we got to do it today. Okay. But it's really, when you get inside of that trap routine and the little instructions, you're going to find that it's using device registers, and it's using those device registers as memory mapped I/O. So it's all kind of there, okay, which is kind of cool. If you're me, it's kind of cool. If you're you, your mileage may vary. So the idea here with specific I/O is just that it's just kind of like what it sounds like, okay? You build your instruction, okay? And you call it, okay? I don't even know if do I have any examples of this? I don't even have an example. That's pitiful. But it would be basically like, imagine that instead of a trap instruction, like trap 21 or trap whatever, imagine if instead of that there was like a native instruction in the instruction set with its own opcode for like getting a character. That's all that would be, right? And you could do it, right? You'd need more than 4 bits for the opcode because it's only 16. To do it in the LC3, you'd need to have like maybe 5-bit opcodes. You get 32 instructions instead of 16. The compromise is we'll just do the opcode all ones. That's trap. And we'll write the code for the trap instruction. But that's not native, right? That's not the control unit having a built-in logic to do that. That's a little program that lives in the computer that we can get to. That's kind of the compromise. But a real instruction would literally be like opcode whatever is the get a character opcode. Now, the number one reason why that's less common, and maybe you're already thinking about this, but number one reason is that you're going to do like get character, but get character from where? I mean, you're like, well, duh, the keyboard. No. What about voice activated? What about voice commands? What about multiple keyboards? What about other devices that you can use to generate characters, but they're just plugged in a USB port or something? You know what I mean? And the truth is, multiple keyboards is nothing, right? Thank you, Dave. Yeah, exactly, David. Perfect. On-screen keyboard. How about multiple on-screen keyboards, right? What about like on my phone? If you guys have this, if anybody's like a what do they call us? Language aficionados. But on mine, I will actually show you because it's just fun. I think I'll show you. Let me see. Yeah. Here's this is actually my phone, and hang on, where am I at? There we go. Can you see that? If you're looking really carefully, you can also see I send notes to myself. Okay, that's what I do sometimes to give myself reminders. I'll text notes to myself. I don't know if you can see that. It seems kind of washed out from what I can tell. There, it's coming.
It's kind of bright.
Yeah, there you go. Yeah, your generation, you like it like super dim. My generation, we can't freaking read that.
Oh no, I like bright. It was just bright on the screen.
Yeah, but you see what I got there? Anyway,
Yeah.
I'm just saying, on mine, I've got English, emoji, Bitmoji, Greek, Spanish, Italian, French, Portuguese, German, Greek, no, that's Hebrew, and Russian. And no, I don't. I do speak some of those languages. It's all because of like doing Duolingo and playing around with languages. Just saying, right? So I could pick different, right? I'm going to get a character. You know what I mean? If that's built into the hardware. Also, when you add another keyboard, right? Then all of a sudden, do I have to rev the CPU chip? You see what I mean? So usually what winds up happening is that the built-in instruction in the CPU tends to be more generic, like the trap instruction in the LC3. That just gives you flexibility. That's what that's all about. But everybody uses memory mapped I/O. Okay. Everybody uses memory map. So here's the idea, and I'm going to give you and I'm going to talk about, there's different ways of doing this: memory mapped registers, memory mapped memory locations, and then kind of typically some kind of hybrid. But here's the idea, okay? Listen very carefully, children, while I tell you a story about memory mapped I/O. This is the hand clasp of sincerity, so you can tell that what I'm going to tell you is true. Here's the idea. Rather than like having to, yank on some wires or fiddle around with hardware or do all the other stuff, what if we just said, hey, we'll just take a memory location. It looks like it's in memory to us. Now, the trick, the wink, wink, nudge, nudge, is that it's actually not really in memory. But it looks like it. You know what I mean? You send it to the MAR just like normal. But the MAR looks at it and goes, this is not, that's the sound the MAR makes when it's feeling clever. It goes, meh. It goes,
My computer never made that.
what's that?
My computer has never made that noise. I'm kind of concerned that I've done
No,
something wrong.
No, it has made the noise. It's just very, very quiet because it's very, very small.
Oh, it's
and
like
it happens so fast that it goes by faster, right? And the NDR makes a sound that's kind of like, and then it's down there, but you got to get down to that level to actually perceive it. You got to slow it way down, then listen to it. So the MAR looks at it and goes, this is not actually a memory, this is not a memory location. They think it is, but it's not. I'm going to go over here and I'm going to check with this hardware device. And then if they have something, I'm going to put that in the MDR, right? So the MAR, the memory system, kind of just plays a trick. But it looks to you as a programmer like, oh, you want to see if there's a character available? Just check this one location in memory. Just read that location. If this one bit is set, there's data. If it's not, there's no data yet. Wait on it. Isn't that cool? And then when it's like, oh, I have data, then go to a different memory location, read its contents. That's the data. See how easy that is? Now I can do all of my normal kinds of, operations, reading and writing to memory, but I'm actually communicating with a keyboard or communicating with a speaker or with a monitor or with something. That's cool. That's cool, I insist. That's cool, I assert.
Yes, I agree.
Thank you, Chris. So yeah, it is kind of tricky, Jay. Absolutely. Yeah, so you can use regular load and store, and right now, when you do the memory mapped registers, you can do these in different ways as well. One is that you literally have like I/O registers, and you read and write to the registers, which is still a form of memory, but it doesn't look like you're going out to memory. It looks like you're reading and writing R0 to R7. Okay. Now, in a sense, it's kind of what we do when we do like a trap instruction and we do like get C, and the character winds up in R0. That's the feel. That's the feel. Now, it turns out that's not really what's going on here, which I'll explain. But that is the emotion. That's the feeling you get. Same thing when you put a value into R0 and then call, what is it, out? I think it's out. That has a similar feel to this idea of a memory mapped register. Memory mapped locations, but the idea would be, okay, that for memory mapped registers, you use instructions that are to push, to load things into registers and or to store things from registers out to other things. You use the register instructions, okay? For memory mapped memory locations, you use the memory access locations. That's the main difference, okay? So that some memory locations are kind of connected to I/O devices. That's it. You put a value in the memory, it goes to the monitor, etc. I explained all that. Okay, now, the LC3 uses the memory mapped I/O. And here's the idea. These addresses from 0000 to FDFF in memory, those addresses in memory are actual locations in main memory. Okay? Above that, from FE00 up to FFFF, those, there is no actual main memory for those. Okay? They are I/O device registers / I/O device memory mapped things. Okay? And I understand that there's a little bit of confusion because of register. And I try to make any of the homework or exams not dependent upon that trickery. Okay? But yes, there are I/O registers. And yes, they're mapped to certain memory addresses, and so the terminology gets a little bit confused. Okay, that you'll talk about I/O registers. There are also special purpose I/O registers that have names in some hardware systems. That's the point of confusion. In this case, they're still I/O registers, but they go by the name, FE05. Okay. They go by the name of the memory location. And you use memory access instructions to put stuff in and to pull stuff out. Okay? Is that clear as mud, to use an old, way overused, cliched expression? Okay, now, here's the problem, because there's something I want to show you, and we're just going to save the time. But you can watch this on YouTube. You can also check the reference. And I'm not sure the best way to do this. There's a couple videos. Anyway, I'll let them roll so they'll show up on the YouTube video. But on Discord, I apologize. Wait. No, I can do this. I can do it. Hang on a second. I just had an apostrophe. Hang on a second. I think that if I let it run on YouTube, then there's a delay, and then I crank my phone, it'll be delayed, but the audio will be there. I don't know. Nah, never mind. Nah, I'm not as smart as I thought I was. Yeah, I can. Yeah, Bradford, I can drop the links in the chat. But some of these will be obvious. You can go look for them. Okay, but here's the deal. This is a concept that is really, 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 really important. Okay, it is about asynchronous versus synchronous. Remember discrete versus continuous? Do you remember that debacle? Do you remember that some of you still don't know what that is? Do you remember that? You remember? Do you remember when Chris doesn't know that still? Do you remember that?
Yep. I don't even know what language you're speaking.
I know exactly. I'm speaking Russian. Yeah. So this is like that. This is another one of those kind of like core computer / software system ideas that are really, really essential. Continuous and discrete is also really essential. Okay. Async versus sync. Yeah. So the issue really has to do with timing. All right. Now, here's the interesting thing, and this is important. When it's time, I'm going to ask you this in the homework, and I'm going to ask you this in the module exam for module 10. Probably 10. And some of you are going to make this classic exam taking mistake. You're going to memorize. Now, this is not something you should have to memorize. This is something that should settle into your heart and just be part of like what you know. Okay? But you're going to go, sender and receiver have to be in lockstep. Then you're going to go, synchronous is when the sender and the receiver are in lockstep. And I'm going to give you 0 points for that. Now, the reason I'm going to do that is because that actually is not the definition. Okay? In the same way that synchronous is when things are inconvenient. You see what I'm getting at? Synchronous is when things are impractical. No. Synchronous can be impractical. Synchronous can be inconvenient. Synchronous requires that the sender and the receiver be in a certain kind of lockstep. All of those are true things about synchronous, but none of them is a definition of synchronous or an example of synchronous. Okay? Now, do you understand that? And this exonerates me. So anybody who does that, 0. That's the sound of a 0 being delivered by a grader. Here's your key term. The key component is Chronos. Do you remember The Incredibles? No, it has nothing to do with that, Chronos. Chronos, Chrono, Chronos, from Greek, it refers to time. Time. This is your key idea. Okay? Synchronos, asynchronos, with time, without time. Okay? Put another way, at the same time, not at the same time. Okay? That is still not a full definition, but that is in fact a partial definition. Synchronous things have to happen at the same time. Asynchronous, chronology, right? Chronological, anachronism. Anachronism is something that like doesn't fit the time. You know what I mean? Like somebody wearing a wristwatch in a movie about Roman gladiators or whatever. Those are anachronisms because they don't match the time. But anyway, that's what the whole chrono thing is about. Synchronous, asynchronous, okay? So at the same time, not at the same time. Now, the reason that lockstep doesn't do the trick is you can use asynchronous methods, like texting is asynchronous, right? Because I can send to you and you don't have to be listening at the same time. But you might be, okay? But you don't have to be. And I can text you, then you text me, then I text you, then you text me. Are we in lockstep? Yes. But we're in a kind of an asynchronous lockstep, right? If I have an email exchange, are we in lockstep? Yeah. But email is asynchronous, okay? If somebody posts some music, so yeah, okay, so a phone call is synchronous. Yes, Morgan. A phone call is synchronous unless you're leaving voicemail. And because, and here's the real key. Right now, those of you that are live on Discord, this is a synchronous experience, okay? Because my voice is making, actually, this is these are sound waves. My voice is making compression waves. They're picked up by this mic, filtered through my beard into, but now they are discretized. Let's bring back discrete and continuous. My audio signal that comes out of my face or any other part of my body, any sounds that I generate, or that's this pen, right? Those create sound waves which are continuous. My computer, starting with this microphone, takes those signals, channels them, and I truly don't know whether this is the chunk that is discretizing, or I don't think it is. I think it's actually just channeling the audio signal in a continuous electronic format. Then it is discretized into samples, chunks, which are then assembled into packets, sent across the interwebs to Discord, to YouTube, right? And they go everywhere. Then when you play it, and those of us that are happening right now live, then you listen to it. Then it comes out in your headphones or on your speakers, and that's continuous now. Okay? Now, it is synchronous in the sense that and now that all happens really, really fast, so the delay, the latency is really tiny. And that's why it feels live and it feels real. If you're watching this on YouTube live right now, of which there are one, and it's probably only me. So nobody right now on YouTube. Okay, fine. But if somebody then watches the YouTube video later, they are having an asynchronous experience, and you can tell because they can pause it, take a bathroom break, do whatever, replay it, right? That the data is just there, and they don't have to have been here right now. But if you were in some live situation, what's that?
I have a question. So
Yeah.
to solidify my learning here for synchronous and asynchronous.
Yep.
So synchronous would mean it's always continuous, always going at a constant rate of, a rate of time. But asynchronous, you can pause it and then rewatch a video over and over again. Is that a big difference between the two?
I think there's a couple ideas that are a little bit confused in there. First of all, you use the word continuous, which it doesn't have to, it can be discrete and packetized, if you will, which is how we're doing this right now. You know what I mean? It started off continuous, then it got discretized, packetized, sent across the internet, received, right? And then made continuous, and then audio sound to you. So that part is not what makes it synchronous. It's the part where right now, if you just muted your mic, right? Like here's an example. Okay, right now I'm going to mute my mic, and then I'm just going to keep talking. Right now it's going to YouTube, okay? And then I unmute my mic, okay? Now, when I unmute on Discord, the sound keeps going on YouTube, okay? So the recording on YouTube has that audio, and you can go look at it later. You can go listen to it later. I didn't say anything, nothing meaningful. But for everybody who is listening right now on Discord, the moment was lost, right? And if there was no recording, of anything, it's like, I don't know, the moment was there, I was there, and all of a sudden I heard a shot, and I looked, and there was already somebody on the ground, and I missed the moment, right? So if I'm watching a movie and I fall asleep in a movie, right? Or I'm at home, right? I'm watching a movie and I fall asleep and I miss it, I back up, right? Because that's not synchronous. It's an asynchronous experience. So even though while it's playing, I'm enjoying it and it's happening, we're in real time, but that's just how I'm consuming it. That's not the nature of the thing. And then I can back it up and play it again. But if I'm in a play, right? If I'm sitting in a play or in a concert, right? And I fall asleep in a play and 2 minutes goes by, I missed it. It's gone. It's not coming back, right? Does that help? So phone calls are, so here's the deal. A play is synchronous because when I'm sitting, I have to be sitting there physically, and I have to be listening while they're talking or while the events, and a live concert is synchronous because I have to be listening while they're playing. And
But if it's recorded live, if it's a recorded like type of play, then you can make it asynchronous by going back and reviewing it over and over again.
that's right. The recording is asynchronous.
Yeah. Mm-hmm.
Right? The recording of that play is an asynchronous communication form because I don't have to be there at the time it's happening.
Mm-hmm.
Cool. So, and this is also kind of key. So billboards are async, right? Everybody buying?
Yeah.
I mean, I have to be driving down the freeway and see it in the moment I'm driving, but when I'm done driving, the billboard's just standing there. And if I'm not actively listening, then they're, watching, the billboard's not, okay, there's no communication. It just sits there, waiting, just like a recording or a YouTube video or an MP3 file or whatever. Okay. But if we're having a private conversation over dinner and we're just sitting there, we're talking and we're enjoying our food, we're sharing, that's a synchronous experience. Okay. And I think I might change that lockstep because the thing about lockstep, I don't like this, okay? I need to make this slide better. I'm making a note to myself.
Yeah, that could potentially throw some people off.
Yeah, exactly. I just don't think it's clear. I don't think it's clear enough.
Yeah. It kind of sounds more like it would be leaning towards asynchronous.
Yeah, exactly. Now, so the thing about synchronous versus async, it is true that synchronous is typically more inconvenient, more impractical. Back when I was a youngster, you had the analog phone, right? It literally was a mechanic, the device, that was a mechanical device, right? And, it was, you were creating a phone call with sparks, right? But when the phone rang, everybody, somebody had to get up, go walk over to where the phone was mounted on the wall or sitting on some table, right? And pick it up. And if you didn't pick it up, it would just ring for a while. It wouldn't happen. There'd be no connection. It was purely synchronous and it was really inconvenient. And then there became answering machines, right? And then the answering machine would pick up, you'd leave your message, and then it would be recording. So you would be in a synchronous communication with the caller and the answering machine. They would be in a synchronous communication, right? This is also why if you just go, async, answering machines. No, not unless you say some more words. Because when I call and I'm talking to the answering machine,
that's synchronous.
That's a synchronous moment, right?
Uh-huh. But you viewing it later is asynchronous.
That's right. But it creates a recording. Now I can have an asynchronous relationship. And here's an example of that. Sorry, I'm looking at writing, "Will you marry me in the clouds with a plane?" is synchronous. It is only synchronous. Yeah, thank you, Michelle. It depends on where your fiancé-to-be happens to be at the moment. I would view that as being dangerously async. Well, no. It's synchronous because, right? Because the smoke, whatever they do that with, is going to start immediately drifting away. Yeah. I think that's synchronous. On the other hand, I don't know. Don't use that one on the exam. Okay.
I guess a simplified way of saying synchronous and asynchronous in my mind. I was just looking at the group chat and it's dealing with text messaging. So if you're constantly in the moment of texting someone back and forth, that would be synchronous. But if you get the message later and then you go back to that message, later on, then that would be considered asynchronous because it's not in the moment, it's later on, right?
Yeah, no, exactly. And by the way, Jay, you know, curse you, my son. You have no, wait, no, it's okay. It's okay. The baby is us. The old woman is 2020. I think that's fair. As
Yeah,
long
that
as
is
we keep it metaphorical. Yeah, thanks, Jay.
final syndrome.
Okay, gotcha. No, here's what I want to say. Back in the day, I'm going to do a little bit of music trivia, okay? One of my favorite bands of all time is They Might Be Giants, okay? I think they're just genius. And back in the day, they started in the 80s. Yeah, they actually started in the 80s. And they used to do a thing called Dial-A-Song. Now, their Dial-A-Song still exists. But what they did, it started when Flans had this old answering machine, like a audio tape answering machine in his apartment in Brooklyn. And then they just posted this number. And what he would do is every single day they would just like make up a song, they would record it as the message on the answering machine. It wasn't like welcome to Dial-A-Song, it was just like dun, dun, dun. They'd do the little song, and it would be crappy, you know what I mean? It would be like, it didn't matter what it was. It was just a way to force themselves to write songs. And they became really great songwriters. And then they posted in the local, like Village Voice and the local, like in the personals, they would post just Dial-A-Song and just the number, make an ad for it. And then people started to call in to this number, right? To listen to the song of the day. Every day there was a new song. Okay. Now was that synchronous or asynchronous? It's an interesting one. They post it, that's an async thing. But this is the interesting thing. Because of the nature of answering machines, not voicemail, answering machines, when you dialed in, you were the only connection to that answering machine. And that was part of the thing. If you dialed the number, I actually did this a few times. If you dialed the number and the song started to play, you were the only person in the world because you were in a synchronous connection to the answering machine to hear that thing. So that again is kind of like, it kind of captures the paradox of this asynchronous delivery mechanism that anybody can now access because it's been posted. But when you make the connection, you're in a synchronous situation. It's a little bit subtle, and probably some of you are like, God, enough. I don't even know what discrete means. Now you're throwing the async concept at me. Okay. But also, and I don't know who said it, but this is really, really true. If we have this engagement, relationship, we're engaged in a conversation via text, and I text you and you text me, and I'm sitting there waiting, you know what I mean? You've done this. And then I respond. That is synchronous. So if you say texting, no, that's not a correct answer. Texting can be synchronous or asynchronous. Okay? Are you with me? All right.
Gotcha.
And any They Might Be Giants fans? Any There Must Be Giants? Let me see. David, the text is asynchronous whether you get it right away or not. Yes. Essentially what you're doing, David, is you are building a synchronous communication mechanism out of asynchronous components. Right? Does that make sense? I know the last thing David said was he was confused. Okay. All right. Right. It's asynchronous components. And all of the data communication stuff, packets being sent, these are all really at some level asynchronous components. But we put them together and we make a synchronous experience. So it really has to be almost viewed from the experiential perspective. Yeah. Would it technically be async? Because it has to take time to get to the tower, then to your phone. Rather than seeing, and Tyler, yes. but you build a synchronous experience because the synchronos means as you're sending, I'm watching. I'm waiting. Here it is. And now I respond while you're waiting. Here it is, right? Like pen pals back when that was a thing, right? You send a letter away. I had a Korean pen pal when I was like 10. Send letters to Korea, which is weird. Back, I'm 10 years old in Iowa and whatever, right? It's a combo because there's a certain synchronous nature. It is tricky. Okay, I'm going to move on. And yes, Bradford, I would say that everything is a bit asynchronous in discrete systems. Because there's always a latency where something has been done and it's waiting and it's going to be forwarded on. Even the part where you're typing, right? Is that synchronous? I'm typing and it's appearing. Well, every character I type goes into a buffer. The operating system has to pull from that buffer. That's why if the system bogs down and I'm typing away, it'll pause and then a bunch of characters will go. Okay, that doesn't feel super synchronous, does it? Even though broadly it is. It's subtle, okay? And life is like that. A lot of these, if you're looking for like clean black and white thinking about stuff, you're going to be perpetually disappointed if you're thinking. Okay. But one thing we can say for sure, in continuous systems, if I'm talking to you in person and there's no recording devices, that is a synchronous experience. We can say that, I think, confidently. Because I literally have to perceive in my tympanic membrane, aka my eardrum, I have to feel the actual vibrations generated by your mouth. You know what I mean? They're not like buffered and forwarded. There's no buffering and forwarding going on there. They're moving and they arrive continuously. Okay, I'm done with this. Are we done? I am done with this concept. And I just want to refer you to, I don't have the audio. I have the audio, but it'll only play on YouTube. Okay, do you remember this one from Zootopia? It's a great
really
scene. Because the sloth, because what you have is a mismatch, right? The rabbit's like, I don't remember. I didn't really like this.
And the sloth was like super slow, and she's in pain.
Exactly. She's like, there's a mismatch between the speeds. That's what that's really all about. Okay. And so I'm going to, I'm just, unfortunately, until I fix my problem, but I'm going to do this.
Hey, Flash, I'd love you to meet my
friend.
friend.
In fact, if I had, wait. Can I get subtitles? That's the other answer. I can do this.
Officer Judy Hopsey.
So what she's going,
I am
doing
just
Fine.
as well.
Then she goes, fine. Right. So anyway, that you got the idea. That's my impersonation of this scene from Zootopia. All right. You got the idea. All right. So things that I think are examples. We talked through these already. Caller ID has kind of an async, right? I look at it. I find out later on who called me. Voicemail transcription, email texting, social media. Life is mostly async by nature in the sense of, I leave a thing for somebody else. But there are these elements when we are together, right? Now, this one, you need to see this. This is also very, I'm going to play this, and if you want to watch it, Gary Goldman, this is how long is this? It's 42 seconds. So if you want to I have to put this here for the record. Go watch on YouTube. We are at, I don't know where we're at in the video time, but I'm going to run this thing and I'm going to be able to hear it. Anybody on YouTube will hear it. And Gary Goldman, in my view, is the funniest comedian working today. That's a bold statement, and I understand that. But I think Goldman is freaking hilarious, and he is my guy. And if you go check out my Twitter feed, you'll see a picture of me and Gary Goldman.
The phone, my parents had a very different experience with the phone. This is good. They used to talk to people on it.
So, He's talking about my parents had a very different experience with the phone. They used to talk to people on it.
And to me, the phone is this seldom used app on my phone.
And he says, to me, the phone is just a seldom used app on my phone. This again, to me, I like this because it kind of like, it just blends this whole, the difficulty of teasing all these ideas apart. You know, but back in the day, you know, we didn't have these phone devices. The audience applauds.
And if you use it on me, oh God help you. How dare you? I am furious when I get a phone call. You text me first to see if I'm even taking phone calls today. And I'll text you back with a window.
So anyway, and then he just says, again, for those that are not over on YouTube, if you use it on me, God help you, right? You text me first and see if I'm even taking calls today, and I'll text you back a window, right? Which I think is, I think it's accurate social commentary about, I feel that way. When people call me, I'm like, how dare you? Who do you think you are? Somebody had better be in the hospital. You're calling me. What are you calling me? You know? Anyway, that's another side issue, but I have children who now don't text and only call, and they also play vinyl records because we all remember how fun it was with the pop and the hiss. That's why we were so jacked when CDs showed up. Okay. But hey, knock yourself out. Enjoy this retro moment. It's beautiful. Okay, now, so what you have to do, how are we doing on time? Oh, we're over time. Crap. Okay. Yeah, let's pause here. Here's what we've got coming up. And we will wrap this up on Thursday. And we will pivot over. And by the way, the actual material when it comes to like homework, you'll notice that the last 3 homeworks are a lot smaller. They're shorter. The module exams are similarly shorter. Okay? Just so you don't freak out. 3 modules. This is not like module 2, okay? Or module 3 or module 4. These are much smaller modules with a few ideas, okay? Because really, once you got hex and the architecture and instructions, once you get these ideas in your head, the rest of it is just kind of like, oh, that application, this is how you apply that. That's the application. But where we got to go from here to wrap this up is we're going to talk about specifically about how to do keyboard from the key. How we're going to do input from the keyboard and output to the monitor, and then we're going to go into the LC3, and I'm going to show you live. That'll be Thursday. Okay, we'll definitely finish that on Thursday. Rock and roll.
Awesome. Thank you.
Alrighty, everybody. Jay, thanks again for that last GIF. My day is complete in a very strange and inexplicable way. or not. I'm not sure. Anyway, take care, everybody.